So I'm going to get started with the first session. Before I begin, I'm going to introduce myself. My name is Castro Mbithi, and I'm the Microsoft student partner at Kibabii University. And I'm sure majority of the people who have joined in the meeting know me because I shared this info about the event mostly on Kibabii University, groups and communities. So I'm going to get started with the introduction to machine learning. It should take not more than 20 minutes. And I'll share my screens with you guys so that you can see what I'll be sharing with you. So I don't know whether you people can see my screen. Someone
no,
can.
We can't. Okay, yeah. I can see your PowerPoint slides now.
Any other person who can see who can't see, so that I can wait for you to be on the same page with us. Guys, you can unmute your mic and reply, and then you mute back again.
Yes, you can see. You can see.
Okay. Let me get started now. I'm going to take you through the basic concepts of machine learning, and the reason as to why we decided to do it this way is because I understand that there are some people who haven't interacted with machine learning before, and I didn't want to start something that is going to be like we start with the coding part, and some people are going to float, because I understand that even when you are learning something new, you have to start from the foundation, like something like baby steps. So we thought of doing it this way so that each and every person can be on the same page with us. So the first thing we should understand is the definition of machine learning, and I'd come up with the definition of machine learning as a set of techniques which helps in dealing with the vast amounts of data in the most intelligent way to derive actionable insights. Now, for this to be achieved, we have to develop algorithms or a set of logical rules. And machine learning is something that you normally interact with on a daily basis, only that you don't know whether you're interacting with it. Like, for example, when you are watching movies on Netflix, it is machine learning that powers many of the services that you use on that platform. They normally recommend some of the things they think that you might be interested in watching, right? And even on YouTube and Spotify and search engines like Bing and Google rely on machine learning to recommend you some of the services or things that they think you might be interested in. Other platforms like Facebook, Twitter, and voice assistants like Cortana, Siri, and Alexa rely on machine learning for them to function effectively. Now, in all of these instances, each platform collects as much amount of data about you as possible. Things like what genres you like watching, what links you are clicking, which statuses you are reaching to, and many other things. A good example is when you search something like, let's say you want to buy a laptop, you search on Google that you want to buy a laptop. When you go to Instagram, you go to Facebook, you go to even on your mail, you will be getting adverts about the same thing. Like they'll be sending you advertisements about something similar to what you are looking for. And I like looking at machine learning as farming or gardening. The seeds which you are going to plant, I normally see them as the algorithms, or the nutrients which are going to be incorporated in the whatever farming. that can be termed as the data, and then the gardener, who is you now, can be termed as the machine learning engineer, who is going to now, like the gardener is going to plant, right? So you are the machine learning, you as the machine learning engineer now is the person who's going to incorporate all those components for you to come up with something. Now, I'm going to the second slide, and on this slide, we're going to discuss a few related fields to machine learning. And the first one is AI. I'm sure majority of the guys who are in tech are familiar with AI. And AI refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. Now, in AI, it's where we program a computer, and in AI is where we program a computer to make to take a rationale, and by rationale I mean the basis of taking a decision. I'm sure most of you have been watching movies that have some aspect of AI, and you normally see that those bots have that aspect of making a decision. Like a bot can make a decision like you can make a decision. They have some knowledge which has been instilled in them, and it didn't just get instilled in them and then they started functioning like that. That bot has been learning with time. It has been learning with time. Like as time goes on, it sees something, then as you know that in machine learning, we normally have the data that has been fed into the system. So that data, which is a past experience, is going to be used by that machine to learn new things, and then it will start thinking and reasoning like a human being. And then we have deep learning. Deep learning refers to certain kinds of machine learning techniques where several layers of simple processing units are connected in a network. Now, these networks are connected so that the input to the system is passed through each one of them in turn. This architecture actually has been inspired by the processing of visual information in the brain, coming through the eyes and then captured by the retina. This depth allows the network to learn more complex structures without requiring unrealistically large amounts of data. And then we have data science, and it is the study of data. It is the study of data, sorry, and it involves developing methods of recording the data, and then you store that data and analyze it to effectively extract useful information, or what we call insights. Now, the goal of data science is to gain insights and knowledge from any type of data we have, whether it is structured or unstructured data. Like you want to gain more meaning from that data. That's why you need to analyze it so that you can understand it better than it was before it was analyzed. And then we have robotics. Robotics means building a programming robot so that they can operate in complex real-world scenarios. And in a way, robotics is the ultimate challenge of AI, since it requires a combination of virtually all areas of AI. For example, things like computer vision and speech recognition. A robot will require that so that it can use it for sensing the environment. The robot will also require natural language processing and things like information retrieval for processing instructions and predicting consequences of potential actions. A robot will require things like cognitive modeling and affective computing for interacting with and working together with humans. It can't work together with us if it's not having that aspect of cognitive modeling and affective computing. And then many other things the robot will require, and this can't be achieved without them relating with each other. Many of the robotics related AI problems are best approached by machine learning, which makes ML a central branch of AI and robotics. And then we have the last one, which is data mining. Now, data mining deals with certain specific information, and I normally meet with many people who have an issue differentiating between data mining and machine learning. And for me, it's very easy. Machine learning solely concentrates on performing a given task. And then when it comes to data mining, you have to mine data so that you can use it later to do something else. And let me cite let me cite an example which will help you guys remember the difference. Like somehow to dance, teaching someone to dance is machine learning. And then when it comes to you telling someone to find the best dance centers in the city, that is data mining. You're telling that person to go around cities looking for centers that have the best dance places. So like that person will go with a pen and a paper and they'll be writing down, I found this place in Nairobi, I found this place called so and so in, let's say Kisumu. That's data mining. But for machine learning, you'll be teaching that person to learn, just teaching them. So every day they'll be learning something new, and then with time they'll have gained enough knowledge to do it on their own. The next slide, we are going to discuss how exactly we teach machines to learn. Now, we have yes.
Hello. Okay, I'm Rico. If I may interrupt,
Yes, yes.
At least maybe you can expound a bit on data analytics. Is it the same, or is it the same as data science, or maybe it's a different field on its own?
Okay, we'll have a session for answering the question. So maybe you can finish the first session and the second session. Then the last session we can now dig into the questions. Is that okay?
It's fine. It's fine.
Okay, thank you.
Okay.
Now we have the next slide. It's how exactly we teach machines to learn. Now we have data that has been collected, or data that will be extracting from several files. Like we have a text file and spreadsheet. We have SQL databases. Now that data is going to be fed into a machine learning. Okay, like you'll be taking that data, and then like you'll be taking that data and then you start cleaning it and then doing a lot of stuff so that data can produce meaning to the user. So the moment you have your text files and your text files are spreadsheets and SQL databases, you'll move to the next step where you will abstract the data, and I mean like providing only essential information to the outside world and hiding the background. Like there are some things that are not relevant. You'll have to do away with them, and then you only pick those aspects of that data that you think is relevant to the model that you are creating, or to the user who is going to be in need of that data. And then after that, you are going to generalize on what you have already cleaned and then done all that stuff. Then in the generalization stage, it's where the learning from the previous step is used to develop an insight. And as I've said before, an insight is like making it's like I don't know how to put it. Like an insight is like taking knowledge out of that data, like making it make meaningful. I don't know how to put it. Like have a meaning to what you had intended, like your objectives. Yeah. And then the next slide is I'm going to take you through the steps used in machine learning. And the first step, you have you collect your data. And in collecting the data, whether it's raw data from Excel sheets, like we have seen from the previous slide, whether it's from Access or text files, this data is going to assist you in doing whatever you want to do with your machine learning model. And in this step forms the foundation of the future learning. Like the better the variety of data that you have collected, the density and volume of relevant data, the better the learning prospects the machine becomes. So you have to collect a good amount of data for your machine learning model to become effective and a good machine learning model. And then we have preparing the data. Any analytical process on the quality of the data used is where you prepare the data, and one needs to spend a good amount of time determining the quality of data and then taking steps for fixing issues such as missing data and treatment of outliers. And I think in preparing the data, it's where you clean your data and make it clean. Like you might find you have some Excel sheets, and these Excel sheets have some columns which don't even have names. So it's in this step where you will give those columns the names that they deserve, and if you have any text fields that are missing data, it's in this step where you prepare your data to ensure that it's presentable. And then we have training a model. Now, in training a model, this step involves the appropriate algorithm and presentation of data in the form of the model. The clean data is split into two parts. We have the first part, which is train, and the second one, which is the first part is training the data, and the second part is testing the data. Now, the second part is normally used as a reference. And then we have evaluating the model. Now, to test the accuracy of a model, the second part, which was the second part of the data, which is testing the data, is used. And then this step determines the precision of the choice of the algorithm based on the outcome. A better test to check accuracy of the model is to see its performance on data, which is not used at all during model build. Like you take in foreign data that you have not used before. Like, okay, you are not going to take the data that you are using to develop the model. In this step, you'll have to take data that hasn't been used before, and then you try and see whether it will give the same result as the data that you had used before and tested with. And then we have improving the performance. Now, in this step, it involves choosing a different model altogether, or introducing more variables to augment the efficiency. That's why significant amount of time needs to be spent in data collection and preparation. So it's very key to spend time when you are collecting your data, so that you'll have something that, even if it's not 100% perfect, it's something close to making things look perfect. Now, the next slide, we are going to discuss about types of machine learning. And okay, I understand there might be others which are not in the slide, but these are the ones that I saw that are key and should be discussed on this meeting. And the first type of machine learning, we have supervised learning. Supervised learning is also known as predictive model. And in predictive model, as the name suggests, is used to predict the future outcome based on historical data. And in supervised learning, the most prevalent, the data, it is the most prevalent. Supervised learning is the most prevalent, and the data is labeled to tell the machine exactly what happened, what patterns it should look for. For example, you can think of it as something like a sniffer dog. I'm going to use a dog. Okay, I love dogs. I normally love. Let me use an example of a dog. Like a sniffer dog will hunt down targets. Once it knows the scent it's after, that's what you are doing when. That's what you are doing That's what you are doing when you press play on a Netflix show. You are telling the algorithm to find similar shows. And the second one is unsupervised learning. And in unsupervised learning, the data has no labels. Like, okay, you saw in the first example, the data had labels. Now, in unsupervised learning, the data has no labels, and the machine just looks for whatever patterns it can find. And then this is like let me use an example of a dog. This is like letting a dog smell tons of different objects and sorting them into groups with similar smells. Now, unsupervised learning unsupervised techniques aren't as popular because they have less obvious applications. And interestingly, they have gained traction in cybersecurity. They normally get used in cybersecurity more frequently than they are used in any other or whatever. What reinforcement learning, and a reinforcement algorithm learns by trial and error to achieve a clear objective. It tries out lots of different things and is rewarded or penalized depending on whether its behaviors help or hinder it from reaching its objective. Now, I'm going to give an example of a dog again. Like those who are dog keepers, you normally, okay, when you are training your dog, if you want the dog to grasp some of the things you are training it first, the moment it learns something and you give it a biscuit, the next time it will try and do the same. Like it will try and learn as much as possible for it because it knows that it's going to be given something to soothe it. And like, okay, this is like giving with all rates when teaching a dog a new trick. Now I'm going to the next slide, which is about applications of machine learning, and I've only picked 3. I know there are many. I can't talk about all of them on this slide, so I'm only going to talk of the 3. Now, the first one is banking and financial services. Machine learning can be used in banks to predict the customers who are likely to default from paying loans or credit card bills. Now, this is of paramount importance as machine learning will help the banks to identify the customers who can be granted loans and credit cards. So machine learning can help those banks know this person doesn't pay our loans. Like, I'm sure most of you have borrowed money from Timiza, from just name them, Fuliza. So they're going to use a machine learning model to determine whether you normally pay their loans or you don't pay. Another thing I normally see is when you're trying to borrow money on Fuliza. For you to be given a loan, they normally, I heard someone say that they normally check the amount of money that you transact on M-Pesa. Okay, like I tried borrowing money from Fuliza yesterday, and when I tried, I don't know how, okay, I tried sending money to someone, and I was only told that I can be given 900 bob. So I don't know which algorithm they use to determine that, because I normally spend a lot of money transacting on M-Pesa, and I was expecting them to give me something like 100,000. So I think they might be having a model, but it's not perfectly built. I think there might be something wrong. I don't know. And then the second part is healthcare. Now, machine learning can be used in healthcare to diagnose deadly diseases based on the symptoms of the patients and tallying them with the past data of similar kind of patients. So like if someone, let's say, for example, like right now we have the coronavirus. So let's say in future, the data that the guys who are doing research are going to collect, maybe if something of, if something similar to coronavirus maybe comes in future, the data that they are going to collect right now is going to help in future to to diagnose and treat those patients that are going to be affected at that time. And then we have retail stores. Now, it is used, machine learning is used in retail stores to identify products which sell more frequently, and slow-moving products which help the retailers to decide which kind of products to introduce or remove from the shelf. And I think that's all for this session. I don't know whether I talk 20 minutes is agreed. So I'm going to give Korede, the next speaker. It's time to introduce us to Python programming. Korede, welcome.
Thanks everyone for joining. Yeah. So for a start, as I said, we'll be walking through so we'll be walking through a basic hello world program, then go on to what Python functions are before going to functional structures and loops and classes. So for a start, to run Python, you could basically, if you have your Python software installed on your machine, so you could basically do a simple Python command to run Python code. So to kick off my terminal here, I would say, run the Python command to load up the Python shell on my CLI. So there are various Python versions. There's the Python 3 point something, the Python 2 point something, and the Python 1 point something. So the recent versions are the 3 points. So to use the 3 point versions, you need to append a 3 after your Python command. So I'm going to do that now. Let me bring this guy up here. So so I'm trying to fire up my Python 3 version now. So I have errors on my Python 3. So to write a basic hello world program on Python. So you could basically fire up a print function. There's an inbuilt function called print, which helps you brings out outputs on your on the output system. It could be on a web page or on a console or a terminal as this one. So for a start, I'll be writing the print statement with the basic hello world. Wow, I think I have an issue with my keyboard. So print say hello world. Or it's saying I have a syntax error. Okay. So this is probably because of the quotation around the string, around the print statement rather. So I don't know why this is saying syntax error actually. So okay, I misspelled the Python word. So instead of putting age, I put J. So I wasn't actually the Python shell. I didn't check. So I'm going to write a basic print statement. So I was wondering if you include double quotations or a single quotation, it shouldn't really matter. Yeah. Oh. Okay, so we have hello world on our Python shell. So there are various ways to output statements in Python. So as I said, that you could output your statement via the terminal, via a console, via a web app, or even an hardware. So I would be showing another example of how you could write a Python, how you could run a Python program. So I'll be using the VS Code editor. So let's say let me name this file.py. So to save a Python extension, if a Python file rather, so you need a .py extension. As in JavaScript, you save with .js in Java I believe .java. Yeah, so in other languages, so languages have various extensions you should save their contents with in order to get them run in real time by engines. So I'm saving this as file.py. So I could do the same thing I did here. Say print hello world. So but while saving Python contents in files, say you're working on a web application. So if you're not using the Python shell and you're writing Python files separately in order to compile, so there has to be there have to be functions. So functions are where the runtime engines look into in order to compile pieces of your code or to output your statements. So for a start, I would be declaring. So that takes us to Python functions. So in order to define a function in Python, so I believe everyone can hear me. Hello.
Yes, Korede, I can hear you. I don't know about the rest. Can you guys hear him? I can hear you clearly.
Awesome. Awesome. So in order to have Python run via VS Code, so there needs to be a Python extension. So you can see how when I did file.py, the icon here immediately changed to the Python logo. So this shows VS Code has identified what kind of programming language or what kind of content I'm trying to add inside this same file because of the extension in front. So if it's a .js extension, it will probably change to the JavaScript logo.
Someone is sorry to disrupt you. Someone has unmuted their mic. Please mute your mic kindly.
What? I believe you can mute them. Castro. Let me do that. Yeah, so as I said, def is a keyword. So the keyword is keywords are basically some code, some blocks of code that have been written by the owners and the maintainers of Python that other users can access. So I will use these keywords to access them in our code. So so as I said, the keyword to access the function definition libraries, the def keyword. So you for a start, while writing functions, you need the def keyword, as I said, then the name of your function. So the function could be func or main, anything. So let's say func. Then the parentheses is there to hold parameters if you're having parameters in the scope convention. So in JavaScript or some other languages, so in JavaScript, this scope uses the curly braces, something like this, So in JavaScript, but in Python, it's a colon, then indentation. Okay. So VS Code automatically recognized the conventions for Python. So that is why it actually indented my code. So if you're using some kind of other editor, you get, so, and the editors do not know where and when to indent. So you could basically run some, some spaces. So the spaces could be 2, could be 4, could be anything, or you could use the tab key. So you use the tab key, it works as well. So going forward, So this is basically how you declare a function in Python. So then after declaring a function, you could write your statement. So in this case, we are trying to output the hello world statement, so which requires a print function. So I'm just going to do this. So print, then yeah, the quotation, and the string you're trying to display. So here is a basic example of printing, yeah, an hello world statement using the file pattern. So if I go ahead and run this, it will give me the same output as the hello world there. So there's another tricky part in Python. So it's the name convention. So it's something I don't know if anyone has gone through any Python source code. So if you actually have, you'd notice some statement like this, a statement that goes underscore. Okay, there are examples there. The main doc file import. So all these snippets, they serve different purposes. So as an example, if you're trying to import a statement, so if you're trying to import a library or a code in Python, and you do not want to declare your import from here, you get. So you could use this convention here. So you could use this import here, you say equals equals equivalent, yeah, then the name of the name of the code or the name of the library you're trying to import. So for this case, we are telling I want to tell Python that this file should be the entry point. When anything I mean could be a web browser, could be an engine, could be a web server, anything. So when the web server anything comes to my folder, so the first thing the web engine should do would be to access the main my main file. So if I do a name, an underscore name format here, and the equivalent sign, equivalent operator here, then say a string that states what exactly this what function exactly, or what exactly this the web server should look into. So I'll be setting this to func. So func here means the name of my function here. So if my function name here is full or main, this one here as well would be main or full. Anything that this this name is here. So then after doing that, so we tell Python. So we tell Python to run the function script. This function here. So I believe we understand this. So let's say you're trying to import import another let's say you're trying to reuse a separate code. Say you have a new file that says new file.py. So and you're trying to use the content inside this, the content inside this file here. You're trying to use the content from here inside this file here. So what you do from this entry file would be to reference this new file here. So you reference the this new file here with the function name, then you indicate authenticate the file here. So that's pretty much how this if name equivalent function works. So let's say if, for instance, I have this block of code that says print, let's say print okay, import. Then we do an import math statement. So to import the math library. So so if I run this line gets printed on the console. So while this doesn't get printed, but runs in the background. So it's like I'm trying, like I've invoked something, but I'm still yet to make use of whatever I've invoked. So another thing would be say say I have print, then say I want to run a function. Let's call this function here. So this isn't actually a function, but it's just a way to tell the console that I'm trying to run a function. A way to tell, let's say, the reader, not the console, say a third party, that a function will be run next. So then I'll declare the function. So function here, the column. So then print function A. So I'm trying to tell myself that so I've actually run I've constructed a function that goes by the name function A. Then I'll be utilizing the function. So what these 6 lines do is on the first line, this gets printed that says import on the console without the quotes actually. Then the compiler loads the math module or the library. Then so what happens basically here is the compiler loads a math module or a math library that's known as written from times past, and it assigns the to a variable called math. So anytime I make a reference of math in my code, so it knows for a fact that it will be running the imported math library here. So this is basically the same thing as saying the if underscore import I said here. So underscore equals then underscore saying the math library that this if yes. So then next this coming. So this def function, as I said, is a way to declare your function. So it's a way to declare your function. You're giving your function the function name. Then this space is where you probably pass in the parameter. So parameters are basically what contents or what variables you want some of your statements inside your code block to work with. So a parameter could be a variable name, you understand? It could be, so the parameters basically are alphabets. So you could say A equals say 1. So parameters could contain strings and integers, but parameters are declared with alphabet. So you could say A, comma B, comma C up to any length. So this shows there are 3 parameters inside this block here. So going forward, let's say if I'm to print something, say assign something to this variable name here, or to this variable name here. So I'm going to do, so you have to write a statement that goes probably C. Say C equals, I could assign a value, a number, and I could assign a string as well to the other variable name. So the string could say probably hello. So this is basically how Python works, how writing functions work in Python. So so back to the hello world statement I made mention of the other time. So we don't need this actually. So what I'll do here is so after writing print function A, so this string could be anything, could be hello world, it could be any statement, anything you want, any text. So then I'm going to go over here to tell to tell Python that if my module, this function here, so if my module, so my module is the name function here from Python. So if my module is equivalent to the if my module is equivalent to the main function here. Oh. So then this function here should get printed. So what I'm basically doing here is I'm calling this function that I've created here. So I'm calling it here. So if I do not call the function, say I just run the code, what would happen is the compiler would understand that there is a function that has been written, but there will be no, even though there's a print statement here, nothing would get out. Nothing would get to show on the console unless I call my function. So that is the main reason why. So that is the reason why I've called the function here. So what actually happens is, as I said, this is the entry file. Since I've indicated that if the name module is equivalent to the main file, then it should run some specific lines. So I'll be naming the lines that I want the engine to run. The functions. So the functions you could call classes as well, functions. So basically functions are objects. So we'll get to that later though. So functions are objects, and they are objects of classes, and classes contain multiple objects. So classes contain functions and all. So what would happen here is when the engine sees my files, it reads this line, then runs the next line that follows. So then after running this line, since this here is a function, yes, it's a function call, so the function gets run. So after this line, basically what happens is this block gets called. So let me just go ahead and save that, then run. So I'll exit this here. Oh. Okay, let me. So if I'm to run a Python file from the console, I would have to declare the Python keyword first in order to call the Python the Python script. So this calls the Python script, then I'll indicate the file I'm trying to run. So here is the file.py. So let's see if we get an error. Yeah. So the error here says if name is equivalent to main, then okay, sorry, the error here says invalid syntax. So our syntax says if name is equivalent to main, then this function should get executed. So which is basically this code here. So what happens, as I said earlier, that when you're trying to assign entry files into the name module, so you need to specify the main function you've written. So here I said main without actually indicating the function I'm trying to execute, the file I'm trying to execute rather. So the name of our file here is file.py. So so this name should go off, then the file should come in because it's the name of the file. So when this is true, then the functions inside this file could get executed. But if you're trying to run scripts, say you're not working on any large application, you could basically delete. So then run your script. So this works as well. What you just do is include the function call. Okay, yeah. So here's the function call. So this gets this gets run. When this runs, then the print line shows the function. So I'm going to return this then save and see what happens. So let us see. So yeah, there is an error. Oh. Oh. So I would come back to this. Also, one then doesn't match any. Oh. Okay. So so there's an issue with my indentation. So it's a big issue in Python 3, Python. I'm coming. So as I said, JavaScript uses the curly braces scope, while Python uses indentation. So while working with Python, you should make it a point to always monitor how well you're indenting your files, because in some cases, yeah, your code would work without without proper indentation, and in most cases it wouldn't without proper indenting. So you see, nothing got wrong since there is no function call. So there has to be a function call before a print statement gets gets output. So I don't know. I'll check closely again why there's an issue with my if statement. So so in order not to waste more time, so I'll go on to the other sections. So so here is how functions work basically. So you declare your function and you include your statements. So you could include if conditions as well. So here's an example of an if condition. So if this statement is true, then this thing should get work done. So so I talked about variables. So an example is the parameters I talked about. So I talked about the func A, B, C, parameters. So these are examples of variables, the A, B, C parameters. So a variable could as well be, so variables do not necessarily have to be inside function arguments. So they could be outside as well. So a variable could be something, say var equals something. So your variable could hold integers and they could hold strings as well. Yeah. So, so there is a method called concatenation. So concatenation is pretty common in JavaScript. So concatenation is say you're trying to join a string with a string or an integer with an integer. So and the operator for that is the plus sign. So you could do say var 1 plus the another integer, say is a number. So what happens basically here is when I do print var, if I do print var, this line here gets printed. So instead of showing the plus operator, so what it does is just joins these two strings together. So say print var. So if you notice, the other prints I did were to include quotations around the var. So I included quotations around the var. So this denotes that when I run this print, what happens is this text gets printed. So let's try that in the shell. So say I do var 1 plus yeah, is a number. This var equals this string here plus the other string here. So if I hit enter, oh sorry. So there's I copied the space here, so there shouldn't be a space before v. So let's run this again. So once this value has been this variable has been accepted and the the assignment, so I could do print. So when I do print here with the double with the quotations, then I say I run the var variable. So what gets printed, as I said, is the var string. So yeah, the codes around the var variables are the ones blocking the print statement from knowing this var contains some assigned values. So I would run that again, but without the quotations. So this gives me 1 is a number. So this plus here is basically joining strings together. So you could join a string as well. You could join a string with an integer in JavaScript, yes, but not in Python. So in JavaScript, if you run var equals string 1 plus 2. So what happens is 12 will get printed in JavaScript 1 and 2, but 12 wouldn't be an integer, but just treated as a string. So if I run this in Python, so let me try running this in Python. So let's see what's up. So it should give us an error, yes. So so why this is giving us an error is because of this error statement here. So the error statement says cannot concatenate string and integer objects. So as I said earlier, Python works with classes and objects basically. So classes could be instances of objects as well. Objects could be instances of classes. Sorry. So this string, this str and int, these str and int statements are inbuilt functions. So they are objects. They are libraries basically, and they are so functions in Python is the same thing as saying objects in JavaScript. So this string and int are functions that have been written, so they are treated as objects. So, but in Python, you cannot concatenate two varying objects together. So in this sense, we are trying to concatenate a string and an integer value. So in order to get this issue solved, so we need to follow the rules of Python. So which is to convert either of these two to a string or an integer. So you could convert this string here to an integer, or convert this here to a string. So what happens is I would include the string function. So I could convert this to a string using the string object, the function. So by doing the str, the star, function. So then I'll include my 2. So if I run this here now, so if I run this here now, I should convert the 2 to a string, then show me 12. So let's try this. So when I now do print var, so it should give me 12, because this here has been converted to a string. So then once this has been converted to a string, then the rule has been, we follow the rule, which is to concatenate string with strings and integers with integers. So now that we are done with variables, so questions would come after this session has been done with. So going forward, I would be walking you through local variable declarations and global variable declarations. So say for instance, I have say a variable name of say var equals 0. So this here is an integer. So whenever I do var, this 0 gets called. So then inside this function definition here, I have var equals 1 plus the string. So when I now do print var, so what should happen is, in the normal sense, what should happen is this var12 here should get printed. This var12 should get printed, and this should be overridden this var here. So so let's try this. So and see the error we get, then we could learn from the error and debug. Oops. Yeah. So you see this. So what happens, as I said, normally we should feel this var12 should have gotten printed. But what happens in the normal sense is this var in the first line would get saved. This first line would get saved, and this var would have been saved somewhere as 0. Then once this function here is from any other has been declared up here. So if this var here is say inside this function, then it's now a local variable. But since it was up here initially, so it's a global variable. So even if I have multiple function declarations, say define function v, let's call this function 1. So if I have 2 function definitions and this var, this var here, and this var here gets deleted. So what would happen for the first print var here would be this 0 would get printed on the screen, while instead of having another 0 to be printed for the second one, this var12 would be printed. So what the output of this would be 0 then 1 2. So because these var definitions, these variable definitions are local variables. So in order to have a variable that could override any other variable declaration within our functions, so we would basically have something called a global variable. So the initial var declaration here was declared globally. So any other place where var is seen, so 0 gets overruled. The other string or integer assignments get overruled, then 0 gets added to the to the value of var. So let's say, for instance, I have okay, say this is number 2. So let's say I have this is number 2 here, but I want any print of the var variable to always show me this, line here, this assignment value here. This is number 2. So if I do want this, then I would have to make this local variable here to be the global variable. So instead of having to copy this and paste up here, so what I would just do is to include a function. So it's an name-based function as well. So it goes by the name global. So what you do is say global then the name of the variable you're trying to make global. So var in this sense. So anyway, so these two print statements would always print this is number 2. So that's basically how global and local variables work. So going forward, so another example would be, to test functions with say arguments. So these inputs here are parameters, while any function, okay, so this print sample here, this print statement here is a function, an object. So but this thing inside this print statement is an argument. So I believe we can see the similarities. So saying print var is the same thing as saying func1, then 1a comma b comma c. Okay, let's just let a comma b comma c, yes. So it's the same thing. This and these are the same. But what makes this different? What makes this different from this is because this is just a function declaration here. So this function 1 here is only a name. So it doesn't do anything in the real sense. So it's just a function name. But this one right there is the real function call, where the where the hard work gets executed. So it's the same thing as this print statement. So somewhere else, this print statement has been defined as, say, define print this, then this, then some statement. And yet, to comment in Python, Python makes use of the hash, the hash symbol to comment out lines of code. So this print statement is the same thing as this in some libraries. So this print word here is a keyword, so which you cannot use inside your code because it has been written as a function somewhere else by the maintainers or the owners of the software. So whenever this print statement gets called, then the print statement checks if there's an argument. So arguments are basically how we override parameters. So these are parameters here, ABC. So and if I change this ABC to say strings or integers, in that sense, say I want my A to become 2, my B to become 3, and the other to become 4. So then all these here are arguments. So if I run ABC, I would run into issues. Say I run ABC as it is, because what I'm trying to say is my A is equal to A, my B is equal to B, my C is equal to C. So, but without, I would run into a type error, same as the one we got somewhere. So I would run into a type error which says this A isn't an integer, because an integer wouldn't be inside a quotation. But strings would always be inside quotations, as strings could be numbers and letters, alphabets, while integers are always numbers. So since this isn't an integer, so I need to wrap it inside a quotation mark. So once I wrap this inside quotation mark, so I could as well change these letters to numbers. So what happens is my function 1 shows the compiler that my A, the parameter, is equals A. So what happens is these ABC strings are arguments. So I'm arguing that I want these parameters to be changed anyway the compiler sees this sees these variables. So I want them to be changed in real time to ABC. So if you can see when I hover on this ABC, there's a text that says str here. So what this str means is this VS Code, there's a Python linter that helps me work with Python. So so this linter has shown Visual Studio that based on the arguments that have been passed, that these arguments and these parameters are strings. So if I change one of these to say an integer, say 5, if I hover on B, it should change as well. So B has now changed into int. So what this tells the compiler is this B is now an integer because of the argument that I've passed. So that's basically what parameters and arguments entail. So say, for example, I want to I want my parameter to take an argument inside my function declaration. So here is my function declaration here. So let's say I want my A to have a function declaration, I'll have an argument inside the declaration without having to include my arguments. So there are various functions that you see inside source code that goes by this. So an example is say this print statement. An example is this print statement. So if I want the user to pass anything that the user wants inside something called the star argument. So inside my source code, inside my code rather. So anytime the compiler says this, it shows that the compiler, that my function 1 would in any number, any varying number as its argument. So it could take 1, 2, as much as possible. So instead of having to declare parameters A, B, C, up to D, up to Z. So you could basically do an asterisk, then the argument keyword. So, as I was saying, you could declare your arguments inside your declaration as well. Say A equals 1, B equals 2, and so on and so forth. So there wouldn't be any need to say 1, 2, 3 up to anything here anymore. So we could just basically run this function and get the output. So going forward, so okay, let me try something. So a minute. So what I'm trying to do is I'm trying to run. I want to debug my int issue. So I want to check for comments inside the chat. If I'm not going too fast or too slow. So I believe we can still see my screen, right? Castro.
Yes, I can see your screen.
Oh, awesome. So as I said, okay, so let me script that we could basically run everything after I'm done with the basic parts of Python. So so this takes me to conditional structures. Or you could probably put conditions to your block of code. Say if this A here is greater than 1. If A here is greater than 1. But mind you, if you're doing A is greater than 1, there should be a function, a variable declaration of A somewhere else. So it could be outside your local function, which could be probably A equals 2. Or inside your local function, anyone. So what happens is, so this isn't an if condition. So I'm just trying to make sense of how I'm trying to make you make sense of how if works and the conditions. So here's an example of how if works, a basic example. So if is an object as well, it's a function that has been written. So you call the function by doing if. You call functions basically by writing the name of the function, then the parentheses. So we've called our if function, and we're trying to pass in some statements to get processed when any condition that will be passed inside this block A evaluates to true or gets true or anything. So then the statement. So let's say I'm trying to check if say, okay, I have my A equals 1 here. So let's say if A, this same A is greater than say, okay, let's say 0 for a start. If A is greater than 0, then the statement. So in JavaScript, you do if blah 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 condition, then the scope. Then inside the scope, you do then you get. So sorry, inside the scope you write the statement. Then after the scope you do then you write some other statements. So before going through your else if constructs. But in Python, what you do basically is to write your if, the condition, then you write the statement you want to process. So in this case, let's check if A is greater than 0. Then let's say the print statement should print true. I'm yet to cover a key part of Python, which is the return, the return keyword. So let me quickly do this before going through what return, what the return keyword is. So print greater than 1. So if I run this program here, if I run this code here, what would happen is, okay, I'm even yet to declare this function, so this wouldn't run. So I need to call my function here. So what happens is, when this function gets created, the first thing this function does is, it gets these parameters. Then after getting the parameters, since we've assigned them, then next thing is to turn our variable to the global scope, then check this condition. Then if this condition is true, then it runs this statement. And if this statement isn't true, if our 1 is less than 0, there will be an error. So let's try that on the shell. So say I have the defined function. Okay, so I have my if condition. So then this here, then the third statement here, then an indent. What indent? Okay. So let me redo this. Ooh. I could basically do this. So I'll go through all this later. So let's just keep moving forward. So the best way to run Python scripts, as I said, is to run from not your terminal, from a real compiler, to compile your file, into probably a folder or something, then run the files from your terminal or a shell or a runtime engine. So, but since I have issues with running, I'll fix that soon. Since I have issues with running the file, so I'm trying to run with my Python shell, which is kind of giving me an headache. So let me just run through what the conditional structures look like, loops and classes, before going back to how to fill this all in and make sense of all of it. So so as I said, when you define the function a equals 1, b equals 2. So what happens is after the variable declaration and the assignment, so and you check if your a is greater than 0. So since our a is greater than 0 here, it definitely prints this out.
Korede, sorry to disrupt.
Hello?
Sorry to disrupt. You can't see your screen. I'm seeing someone by the name of Benjamin sharing screens. I don't know whether it's you.
Okay. You. Okay, it's awesome. So so let me just run through everything here. A quick run through. So I'm coming. Let me delete all of this. So let's say you can have your parameters here. Then do declare assign contents to your variable. A equals 1, b equals 2. So then so conditional structures are how you structure your blocks of code to check for conditions and evaluate contents within your code. So this condition here says if this variable name here is greater than 0, the value of this variable name here, so it should print greater than 1. So which isn't true. So then, so this is true rather, sorry. So since this here is true, the other thing we could check for is if this statement, if we could make this statement false, then something else gets returned. So to do that would be to use the else statement. So for else, you do else, then print something else. So print not true. So so if this here is less than 0, which isn't true, so then just this line will get displayed. So if this here is not 0, it's less than 0, this would get skipped and this here would get printed. So but in some cases where a is equal to 0, where a is equal equivalent to 0. So if our A is equivalent to 0, which is false, then none of this A could get printed. So what happens is this would be skipped. And since A is not equivalent to 0, this A will be printed. So something we could do to check, to do a proper check, to evaluate properly would be to add, because this is just some kind of random guess by the compiler. So what we could do is to add else if statement, an else if block. So the else if block in Python is basically writing an elif statement and the condition. So note how this wasn't included in else rather. So cause else is basically the last check, that else if none of all the conditions are true, then executes the next statement. But else if you're still trying to check if some other things could still be true. So in Python, you could have as many else if as possible. So as plenty elif as you want. So in JavaScript, it's basically writing, in JavaScript is the else if statement. It's else if, then the ternary operator, then it's cool. So these are how the else if works in JavaScript. So inside it, you could pass in the checks. So say A is greater than 0, then this one here could be, and if A is equal to 0, should state, it could even be a return value, return something. So in the return as well could be string, could be a string. This isn't. So the return works as print, but not exactly as print works. So return is basically how you return values, in how you throw back values to the compiler, or how the compiler throws back value to the console or the output engine. So let's say, so now coming back to how return works. So let's say I have this function here, and I want to print A. Say print A. Okay, so this A here will print 1, the value of 1. And I have my function declaration. My function declaration here. So sorry, let me make this return. Return A. And then say print func1. So I'll wrap this inside the object, and let me call it the function. So once this function gets called, once this function gets executed, this line gets run. And once this line gets run, so what would happen is the compiler would return the value
It's
of 1.
3 o'clock.
So when the compiler returns 1, then this other statement here would be executed. So what this does here is it basically runs, it would do the same thing that this does, this function 1 here. It would return the value of 1. But even after returning the value of 1, it would print what this func1 does here. To print, it would output it on the screen, on the console, or the engine, anyone. So say I have no return value. Say I just have a print statement here. So print is different from return in a number of ways. So let's say I have print here, and I have the same, I have a print statement as this is here. So this function 1 here would have an output of 1 here. Then this other line, this line 8 here would have an output of 1. Yeah, which means it would run the function here, which is to output the print here. Then this print again would work on this function. So, and since this doesn't have a return type or a return value, anything, it doesn't have the return statement. So then the automated, the default return value would be none, that no return value was found inside this block of code. So this is basically just it's just shows you how print is different from the return statement. So going forward, let me cover a loop before rounding up. So loops in Python basically they're of two types. So the first one is the while loop, while the other one is the for loop. So what the while loop does is so what the while loop does is it executes your code, your block of code. So only when a particular statement or a particular condition is true. So let's say, let me try on this. There's an error here. So I didn't pass an argument for these values here. So let's say 1, 2. I could change the values from the declared variables. Let's say 2, 3. So as I said, the while loop executes a chunk of code, a block of code, whenever a particular condition returns okay, yeah. So this is why I said the other time. So it would return a value of none. So what happens basically on this line is this func1 here. So this func1 here has arguments of 2 and 3. So this a equals 2 and this b equals 3. The same thing is true here. So and we say print hey. Oops. So if I rerun this again, it should be 2, 3. So if what I talked about global variables and local variables. So this here, in this sense, this here are global variables. So anywhere this argument, this parameter changes to anything else within another scope, then these global variables override any other thing that has been passed. Yes. So if I rerun the code, so let's say I rerun the code, it should show 2, 3. Sorry, 2, 2. We're only printing out the value of a. So 2, 2. So what happens here basically is I have the print statement. Then I have another print statement. So this is exactly what happens. So I'm printing, since I'm calling this function here, and this function already has a print. So then definitely this print would have another print inside it as well, since I'm calling a function that has print already. So this is exactly why there are 3 outputs for 2 statements. So this evaluates to 2 statements, while this evaluates to just 1 statement. So and the reason why there is a non-response there is because of the return value. There is no return value. So if let's say I have a return statement that says return a, yeah. then the value of A gets returned to function and it gets shown on the screen. Then this none would go off. Then when this none goes off, then the none will be replaced with the value of the return value, which is A. So let's quickly try this. So yeah, so as you can see, it shows the two value. So so I was talking about while loop, the while loop. So I said the while loop, yeah, it runs a block of code whenever a condition is true. So this is how the while loop works. So for the while loop, you can have say the function definition. You have the function definition. Then say a statement. Say A equals 5. Say equals 5. Then you can. So after saying A equals 5, then you have your condition, the loop. So the loop construct is so this is how you construct the loop. You call the function, the while condition, the while function. Then inside the parameter block, you include your condition. So let's say we are checking for say whenever 5 is greater than A, or A is greater than 3. So you should do something. So while A is greater than say while A is greater than 3, then so the function should probably, yeah, should do something. So here I'll say while it's greater than 3, then it should print yeah, A is greater than 3. A is greater. Then for the on the next line, I would say so I could do A plus equals 1 to add a count of 1 on every output of A. So sorry, to add a value of 1 on every value of A. So this is some sort of loop. So the value of A changes according to the construct, the condition. So, and I could say, I could replace this as say A equals A plus 1. The same thing as saying A plus equals 1. So so here is how the while how the while loop works. So what you do basically is you set up a condition inside the parameter, then you include a statement, then you pass in and say an iterator, an increment to increase the value. So this loop gets on until your A is equal to this value here. So then whenever your A equals this value, then the condition will stop, the loop will stop. So another type of loop is the for loop. So the for loop is basically saying for. So what the for loop does is it's instead of validating a condition as the while loop does. So what the for loop does is it basically checks iterates it checks through all the contents or all the contents within an array or a sequence that you've provided. Then it outputs each of those inputs list or array or items in that list or array or sequence. So let's say I have, so A is also writes, and write a for construct. So you say for x. So your x could be any other variable, could be a, could be anything. So all these for in and range are, these for in are keywords and the range as well. So for x in range, say 10. What this basically does is this range is a keyword, an inbuilt function, so that checks for the values from an initial from the index up till the given value, the provided value. So okay, yeah. So here is an explanation. So it says return an object that produces a sequence of integers from start to stop. So as I said, it produces values from the index, from the start point of integers up to the provided value. So what this means is it shows, this range would show values from 0 up to 2, 3, up to 10. So then when I pass in, so when I write a statement that says print x or return x, so what happens is it would show me the values from 0 up till 10. So it would count. So as I said, what the for loop does, it iterates over a given sequence. So this is the given sequence, a range of 10, or a range of values from 0 to 10. So then it iterates from the very first one. So it begins the listing from 0, 1, 2, 3 up till 10. Then it stops when it reaches 10. So another thing to note in for loop is, instead of having to check through a range of numbers, you could basically check through a range of say lists. So your list or array could be, say, okay, let's say MSPs. Let's say MSP is equal. So to write an array is basically how you list items. So as I said, an array is basically how you list items. So the items could be integers, they could be strings.
Korede, kindly, can I disrupt?
Okay.
Bethany, I saw you raised your hand. Can you please say something?
Mm-hmm. No, I just wanted to tell Korede that you're raising your hand. But you can continue.
Okay. All right. So say I have MSPs. So I'm passing in string values. So let's say the names of MSPs are anything. So and I want to list these values. So what a for loop would help me do in this situation is to list the items from the index point, which is BD. So 0, 1, 2. So it starts from the very first part. So and when I do when I rewrite my first statement, which is for, so here I could do for MSP and I could as well change. It doesn't actually have to be MSP, so it could be X, it could be any variable. So say MSP, but the sequence that you're checking for should be the same variable that you've declared here. So in the variable MSPs. So and if I do print X, so if I do print X, what happens is, so what happens there is it starts printing, same as what happens with 0 to 10 here. So it starts printing from this list here, starting from BD up to EFR up to EFF. So that's basically how loops work, while loop and for loop. So finally, I'll skim through what classes are. So classes are the real deal when you're working with Python. So you're working with machine learning, web apps, anything. So classes are how you work, how you construct your how you construct your code and how you make sense of what sort of content you're trying to deliver. So how to construct a class, you same as defining a function where you do define the name of the function. So in classes you do the same, but with a different keyword, which is the class. So class, then you could say class name. So class name as the class name as the name of the class. So anytime you want to reference your class, you reference with this class name here. So then the scope, the name of that statement you're trying to run. So inside your class, you can now have as many functions as you want. So functions in this scope are not actually functions, they are called objects. So say I have another function declaration that goes by the name, say class function, class func. And in Python, so in Python,
kindly let me disrupt.
Okay.
Eric has raised his hand. Can you say something, Eric?
Hello.
Eric, I can see you have raised your hand and your mic is muted.
Yeah, sorry, Castro. It was by mistake and cannot seem to lower it. Oh my God. Sorry, just continue. Korede, please. Sorry for that.
Okay.
So this is the very last the very last content here. So in Python you could basically remove this parentheses here, this operator here. So when you remove this still works. So what this means basically is if you want to pass in say function variables or normal variables, you could include them here. Anything. So going forward, if you're declaring functions inside classes, objects, so then you could notice how the code is being indented automatically. So so in JavaScript, if you're writing this sort of thing, nested functions, so you include the scope, then inside that scope you declare the function. Inside that scope you could declare another function, and so on. So but in Python you have to make use of indenting the tab or the spaces here. So say then finally I do, let's say, a print statement. Say print a function inside the class. So so if I want to make this string get output, so if, let's say I want to output this string here, I need to call in my function, sorry, my class rather, because inside the class now. So if I just call this function, nothing will get output. So it's until I make reference to this class that this function could be triggered. So to call your class, to make use of your class, you could do something that's called instances. So instances in OOP or in object-oriented programming is basically how you reference functions inside your class, or how you reference your class. So to reference a class, even right here, you could do something, say class name. You could call the class name. Then so to reference, you do a dot notation. Then the function you're trying to reference, say class func. You could do this, but this gets it gets complex when you have nested functions inside the class. So which is why there is a need for instances. So instances is basically assigning your classes to a variable. So let's say I could assign this class to a variable, say A equals then the class name, the name of the class. Oops. So here, we've assigned our class to this variable here. So anytime we want to reference a function or any statement within our code, any chunk within our code, we could basically do a dot then anything we're trying to reference. Okay, as you can see, the Python lint has automatically shown what I could reference from this class here. So here are inbuilt functions. But this here is the class I created, the function I created, the class func. So I could reference this. So when I reference this, I could do a print. So this is basically how classes work. So I've referenced this. Let's say I want to print the statement. I could basically do a print or a return, anyone. Print say a.class. I'll call my class. And anytime I run this, what happens is this print statement looks inside my class for a class func object. So once it sees the class func object, then it runs it. So then inside my class func object, which is the function, I have the print statement. So definitely this gets run, and we have an output that shows this. So that's pretty much the basics of Python, what you should have as a basic Python developer. So I believe with this, with all of this, you could make sense of it and work on improving your Python skills, because